I was in the highlands in Cusco not too long ago and was talking to people in a couple of communities, some Quechua farmers, and they were saying that the weather is unpredictable. They're having a hard time knowing when to plant and when to harvest because the signals that they always relied on don't seem to be working. Is that climate change? Is that a natural just fluctuations in the weather? How do you tell the difference between the two?
Well, the weather is this day-to-day, year-to-year variability that we have in our system, and there's a lot of variability in that. But it's not to be confused with climate. Climate is a 30-year average of that variability. But I must say, I've been coming to Lima for 35 years, and I've been impressed with the number of sunny days this year at this time of the year. Normally it's cloud covered, foggy, so we all see this variability in the system. But what we're trying to look at with the glaciers, and what the glaciers do so well, is they kind of integrate all the climate variables: precipitation, temperature, cloudiness, radiation, and they sum it up and they respond. And they're all retreating here in Peru, and they have been doing this for the last 30 years.
Tell me a little bit more about what you can find out from glaciers. You say glaciers sum up these things. You drill ice cores, you drill down through the glacier, and you take out a... Tell me what it is that you take out, and what is it that you can read from that?
Well, I say this even though this is what we study. We've been doing it now for 33 years, but I believe the ice is our best recorder of the history of the planet. And the reason is that it records things like temperature through stable isotopes of oxygen and hydrogen. It records precipitation. Very few of our recorders actually tell us how much precipitation fell 1,000 years ago. And by measuring the thickness of the layers in the glacier, you can actually tell that.
And when you say thickness of layers, is this precipitation from every year?
Yes. What we find in the glaciers throughout Peru is because of this very distinct wet season and dry season. In the dry season, you have a dust layer because the whole area is dry, and you can measure that every year in the ice. And you can measure the thickness of those dust layers and determine how much precipitation fell 925 AD in this part of the world. But with that, ice is also recorded volcanic history, tephra, sulfate, anything that's put in the atmosphere comes out with the snow. In this part of the world, you can also look at pollen and get an idea of how plants responded to climate change in the past. And then trapped in the bubbles in the ice is the history of the composition of the atmosphere. And so you can extract those bubbles and measure CO2 and methane and nitrous oxide, all the greenhouse gases that we're concerned about today, and look at what the natural variability has been through time. So anything that's in the atmosphere gets recorded. I believe that here in the Andes, there's a history of fires in the Amazon. As the easterlies bring the air from the Amazon up over the Andes, that gets incorporated in the snow. And by looking at the organic chemistry, you can reconstruct that history of fires long before people had records of these changes.
So as the glaciers melt, what gets lost? What are we losing?
Well, we have been particularly concerned in the last 3 years. We drill all over the world, and we drilled a place in southwestern Himalayas at above 20,000 feet and 6,050 meters. And there, at the very highest places on the mountain, we found that we're losing mass from the surface down. That is, it's no longer accumulating. For a glacier to be a glacier, you have to have an accumulation zone, a place where you have a net addition of material. And then down at the lower elevations, you have ablation, where you lose mass, and the glacier flows down. It is a continuous cycle. It's a system. And what we found is that it's no longer accumulating. And in fact, it hasn't accumulated since 1947. There's been a net loss from the surface down at the source of some of the major rivers, the Indus, the Brahmaputra, the Ganges River. And then a few years ago, in 2000, we drilled the ice fields of Kilimanjaro in Africa. And we found there, what we look for in all these cores, at the top, we look for the thermonuclear bomb test. Every test that we've put off in the atmosphere has left a radioactive layer. We know when those tests took place and where. So all you have to do is identify that layer and you know what the net balance has been. Well, we identified that the Ivy test in Kilimanjaro in 2000, 1.8 meters below the surface. Since 2000, we have lost over 2.5 meters of solid ice from the surface down at the highest places on those glaciers. That is, they're dying. When a glacier, to be a glacier, ice has to flow. It will not flow if there's no accumulation, if there's no pressure put on it. So those glaciers are dying. And our fear is that we will find a similar scenario playing out here in the Andes in the next couple weeks when we go to these places up in the Cordillera Blanca. That those glaciers, I mean, it's all part of the system, and they're starting to lose the mass from the surface down. There are mountain peaks coming out that were not there 15 years ago as this ice thins.
You published an article a few years ago about something that you found in Cusco at the Coricalis Glacier. As the glacier retreated, it was exposing plant remains from thousands of years ago. Do we gain some things too? Are we going to learn some things about what the environment was like before the glacier formed or as the glacier was forming?
Yeah, I think these are incredible. I mean, the fact that you can find a wetland plant rooted in growth position that has been covered by a glacier and not eroded away. And so we first found these in 2002 as this ice wall was retreating and right at the base. And immediately that tells you had to be warmer in the past because those plants were growing there. And because they're perfectly preserved, it suggests that whatever happened was very abrupt, that these plants were actually captured. Since 2002, we have now collected over 50 plants. We were just there last week. We collected 14 more plants at the margins where the ice is retreating. And we will carbon-14 date those.
Do you have an idea of how old they are?
5,200 years in age. And so they tell us that 5,200 years ago, something happened very abruptly that captured these plants. And so we have the question we're trying to answer is, did the Quelccaya ice cap, as we know it, did it form 5,200 years ago due to an abrupt snow event that covered the plateau and buried these plants? Or was the ice cap simply smaller before 5,000 years ago and advanced and down over these plants? And the plants will tell the story, because as the ice fields retreat, if the ice cap was simply smaller, what we'll find is it gets, as we make these collections like this year, those plants will be older than the ones we collected last year and the ones from the previous year. So you can see the time transgression taking place. If it was an event that captured all the plants at once, they will all be the same date, 5,200 years in age. This turns out to be a particularly interesting story right now. Probably it was in 1998, I went to a conference that Thor Heyerdahl, the Kon-Tiki guy, had organized. He brought an archaeologist and a climate person from every continent. And at the beginning of the meeting, he wanted to know two things. He wanted to know why civilization as we know it, the Egyptian, Sumerian, Indus Valley people, started at the same time, about 5,000 years ago. And he also wanted to know why it was suddenly important for people to keep track of time. Calendars were invented. The Mayan calendar was started on August the 11th, 5,112 years ago. Two Hindu calendars in India started within 10 years of the same date on the other side of the world. And why was it suddenly important to keep track of time?